Okay, howdy. I'm Ben House. I'm a technical artist at Bluepoint Games out in Austin. This talk is going to be kind of high level. I can't go into like a lot of detail into exactly how all of these processes are done, but after this, if you want to talk to me or we can ask questions, I can go more in depth with that kind of stuff. So Bluepoint Games, a lot of people don't really know what that is, so quick overview. It was started in 2006 as just a way to make a game engine to rapidly make games. And eventually it kept picking up new projects to port new games. And then eventually we got the title Masters of the Remaster. We didn't call ourselves that ourselves. I think it was Digital Domain gave us that title. But we've worked on remastering Shadow of the Colossus, Uncharted, Gravity Rush, Titanfall, and God of War. Just some of the stuff that we've been working on. So a lot of our processes are a little bit unique in that we work a lot with existing game content and existing designs rather than creating a whole bunch of stuff from scratch. To get into like a bigger overview of what the talk's going to contain, I'm going to go into terrain a little bit. I know Ari Danish literally just gave a talk on terrain, so I'm going to go through that pretty quickly, but it'll give you some insight into like kind of the process that we do and how we use terrain and fix some of the problems and address some things with that. And then I'll go in how we use Vellum soft body simulations for cloth and wind. And then I'll go over our real quick game ready hair process and some high level asset processing stuff that we do just to make artists' lives easier on a day-to-day basis. So going into the terrain stuff. So one of the things that we get a lot with terrain is like the art director will come in and be like, I want a hill here, but it needs to have a slope here at this kind of angle because the silhouette needs to look exactly like this. And in a lot of other terrain generation softwares, you really lack a lot of that really high level artistic control to get exactly the shapes that you want. And Houdini allows us to influence the terrain based on custom input geometry and then convert that to height fields and use masks to do what we want to it. And it basically, we can take a mishmash of meshes that the art director has maybe put together himself and then just project that to a height field. And then once that's projected into a height field, we can add some initial surface distortion on that. And then run the erosion and slump and emulate all the loose materials and all of that kind of stuff. And then maybe add some more surface noise and more erosion. And then we can generate masks to isolate specific places based off of the actual angle of the slope or hand paint any of this stuff in. A lot of times artists will want to hand paint stuff in or procedurally generate it. So depending on how you set up your HDA in your pipeline, for this, we're using it all as like an enclosed HDA. So it's almost all procedurally done. But it's at any point in this process, you can break your HDA up into unique chunks and say, up to here is going to be an HDA. And then an artist will touch it by hand, and then we'll feed the rest back into the HDA, like a separate HDA to continue automating the rest of the pipe. So we have all of these masks, and we can use these masks to dictate all of the different attributes that we want. So where we should put grass, what parts should be rocks, the different noise that should be applied to different sections. And then, as Ari mentioned his last thing, most of the time in games, you can't bring in this massive, huge thing. You need to cut the terrain up into grids. So we do that also. We isolate one grid of our terrain, and we kind of convert all of it to polygons. And then we run a whole bunch of noise operations on that to give us the cliffs and more feature definition. And then we use the VDB operations and VOPs to give more natural overhangs and stuff the kind of detail that you want to see in like a realistic terrain, but you lose with just using height fields. And a lot of times this will get done by hand in ZBrush, and we've kind of figured out that you can use VOPs to get 90% or all of the way for a lot of the noise that you want to get on this kind of terrain. And then we basically just grab the original mesh that we had and combine the new terrain that we've got together, and all of the attributes still go over. After this point, we'll do a really quick cleanup, usually with some Boolean operators and dissolves. And then when we combine everything together, we bring it into the game. All of the attributes are auto-assign all the materials. They put all the grass, they scatter the trees based off of the settings that you've put in and where you've painted your attributes. And you get a really good starting place for your environment artist really quickly. And so this whole process, basically, I'm going to mishmash a whole bunch of shapes together that the art director says needs to look this way. You run it through the pipe, and then out you get this in like a matter of like minutes. And it's just really fast, streamlined workflow to get your artists going, and they can edit it from here as much as they want to. And I've got like a quick preview of it, but you can also use this to generate rivers and like where streams and water bodies should go as well. So next, and we're going to jump into cloth and wind. As everybody knows, Houdini 17 brought in this really powerful vellum soft body simulation stuff. So we wanted to take advantage of that. But we didn't want to run all of this cloth in real time. We wanted to bake it out into skin meshes that animate but still look very realistic. And then along with this, we make use of a lot of Houdini's wind simulations or gas simulations to create vector fields that we use to drive all of our particle effects in game. And I'm going to go into our wind setup real quick. Basically, our wind setup requires a few elements. We need the level geometry and any collision geometry that would be affected by our wind field solver. And then we also need the collision geometry that may interact with any of the vellum simulations that could be affected by this wind. And then we need the geometry that the vellum simulation itself is going to be doing. So this is an example of what our cloud or wind solver will look like. Basically, we just generate a vector field as an FGA running over our landscape environment. And really all of this is a velocity or airfield sim. It's just a DOP gas simulation utilizing velocity and pump velocity with some collision objects. And we run this for as many frames as we need until we start getting some nice patterns and stuff. Basically, when it's all nice and colorful and we get some cool looking swirls, whatever's visually interesting or whatever you need. And then we basically just save out one frame of that and use that as our field in our game engine to drive all of our gas simulations in real time. Basically just tells the particles where to go and how to behave as they move through the air. And so this is like starting fresh to a more complex thing, just so you can get something that's way more interesting than just flat rolling hills. This simulation itself is typically run at a 50 centimeter to 1 meter per voxel resolution, and then we downsample that later in a post-process. The wind field is usually used to drive, like I said, particles, but we also use it for vertex animation, so grass or any of the foliage interactions that we need to behave naturally without a direct character interaction. And really, this is just a really fast, easy way to get realistic behavior out of particles that the effects team then doesn't have to worry about it. We just bake this field out, and then the particles behave naturally in the game. So quick look into getting simulated cloth objects out of Houdini as a skinned mesh. In the example I showed, we have this nice banner. The rigs and animation are processed in several steps. Basically, the flag is broken down into different components for the pins, the loops, the cloth, and the collision elements. And these are basically just assigned with group names or attribute names. And then in this image, we just have the pins that are configured to connect any loops and cloth and the geometry to the collision object, which in this case is the poles. And then we assign any attributes like up vectors or occlusion, and we store those as vertex attributes on the mesh. And then usually the collision geometry itself is separated, and then we run a point cloud across the collision geometry just to evenly distribute points across it when we use these point locations to generate rigs. because in most cases, when you're generating a cloth sim, the thing the cloth is attached to can also animate and bend. So we kind of just combine that in this process and do that. We can remove it later or have it as an option to run or not. So we kind of assume worst case all the time, all elements are going to be rigged, including all of the support structures, just in case animation needs it for whatever reason down the road. So during the actual vellum configuration, the loop and pin geometry needs to get stitched together, and then we run the simulation and cache that data out. And then just like we did with the supporting structure on the poles, that simulation is baked into a point cloud, which we use to drive the joints location on our rig. And we basically we just scatter points and relax them enough to make sure that they're evenly distributed across the mesh so that we get nice deformations as we bake this out. So this isn't as high fidelity as it would be if we were doing this for every vertex, but it allows, when we bring this into game, it runs really nice and quickly in real time. And the final step is basically we just take all of the stuff together, generate a really messy looking skinned mesh rig and bring it into the game. And then we get nice, realistic animation that works with the vector fields. And now I'm gonna go over fast game-ready hair. So I got our nice greaser. So the purpose of this pipe is basically we wanted a way to develop hairstyles and get them into the game as quickly as possible, because we wanted our art staff to be able to block out a new style for the hair and then see it in the game in the same day. And the target platform could change, specs may change, and we didn't want the artist making the hair to have to go through a whole bunch of processes to change it. We wanted to automate this and make it as fluid as possible. So in our case, we're using Maya's interactive groom splines to comb out hairstyles. This is a process that's traditionally used for film and animation. But really for Houdini in this process, any software package that can export splines is used just fine. So it's really agnostic on what software you actually want your hair artist to make their hair in. So we just export the IGS data out as an Alembic cache to process that in Houdini. We have a series of basically just like a kit of hair processing HDAs that we use. And these are broken up into 4, 5-ish main tools. The high-level hair setup HDA is the top thing that feeds in the main mesh and the hair splines. This is used to calculate all of the attributes, such as how the UV should be laid out, occlusion, up vectors for the hair, how thick hair should be, the hair nearest neighbor, roots, tip position, all the attributes that you would need or that your artist wants to define for what they're using with the hair shader and stuff that you need in game. So we store all of that on all of the guide curves, and then we all the results of that are cached to disk, and then those attributes are used and sorted into groups further down in the process as the artist needs to break it up and get more granular with like how to control the polygons that are used to make the hair. For this asset, basically we always assume the worst case, like I said earlier. So we basically assume that we don't have any additional data aside from just the guide curves and the model that the head's going to be on. So there's no other input that anybody needs to use to do any of this. So alongside this process, we compute the edges of the groomed areas. One of the problems that we ran into in doing this is getting like really nice, clean edges around the hairline, instead of like having cards that are like offset down the hair and messy hairlines and a lot of other things that we've seen. An artist would have to go back in and post and like clean up the hairline and move the cards back into position. So we basically volume sample the normals to get the overall hair shape over the skin. And then we generate a cluster of cards to follow the edge so that the cards that are generated blend and rotate to follow the overall hair volume that was defined. The next thing after all of this is done at the very highest level, this is where the artist can go in and isolate particular parts of the hair that they want. So we have a separate delete and selection tool that allows for different deletion modes using the attributes that were created from the setup that they had before. And these options are, again, posted up there, but for more granularity and just letting the artist be an artist in this environment, we let them break it up as much as they want to. We can also use this process to isolate desired areas of detail and remove unnecessary guide terms if you really want to get nitpicky with the hair curves that you use or the specific guides that you want. And maybe like at the end of the process, like everything came out nice except for like a couple curves. Well, you can isolate just those curves and then rebake that out and not have to worry about redoing the whole process again. So the card generator itself is the next main step, and that creates the actual geometry for the hair cards and UVs them. And the hair edges tool, which is a separate process, basically just fills in tiny cards to make sure that there's a nice clean edge along the hairline. So this hair grouping ratio down here at the bottom of the HDA parameters is basically just the cluster points node with different biases that allow the user to add or take away hair clusters from one group and assign them to another based off of some different threshold values. So if I need more hair on the inside or more hair on the top and less cards along the edge, the artist has control over that just by modifying these numbers around. And with all of this, the artist can say, well, okay, I've grouped all of these for one target platform, but now I have another target platform. And they can start with what they've already done and then just copy this node, change the threshold values a little bit, and they have all of the cards baked out for the new target platform that they had. And then this is just an example of the types of cards that can be generated from this process. These are all, the card type is user controlled, so we can have, they can control the shape, the segment per card, the number of cards per guide, so we can get cross sections along the curves or just one flat curve along the guide. And then finally, we just have an exporter, so the artist doesn't have to worry about going file export or leaving out any of the data. There's just a clean export node that cleans up the geometry and exports it as an Alembic to bring back into Maya or whatever system that you need. And kind of the process end result will look like this, where you have the edges, the bottom hair cards, the mid meat of the hair, and all of the outer surface hair cards. And then when you bring this all together, I think this is 13,000 tries, which for like a hero hair is pretty good. I think in Horizon Zero Dawn, it was like 200K. Yeah, like 200K. So that was pretty heavy. And kind of the awesome thing about this system is you can get as high or low as this as you want, and the artist never has to change anything from their original hair guide setup. They just have it how they had it, and it processes through. And if they make changes to it, then they have it using the same settings. They just open up the HIP file, recache it, and boom, it's done. So quick GIF just showing the different angles of the hair, just so you can see it does fill out, and we have control over all of this. It's pretty cool greaser, dude. And then I'm just going to do a quick rundown of one way, just so you can preview the hair shader in game real quick. Basically, we use Maya's IGS to do the actual alpha creation for this. And then we just use the standard UE4 inputs in this example to make our quick hair shader. Alpha and ID and RGB channels are used just to set the different color for hair and depth. And then we use depth and root for the spec and roughness values. And then depth and alpha again to create the edge mask. And at the end, you just get game ready hair assets in less than an hour from when the actual hair was done. And then I'll go into some asset processing stuff. So this is kind of what I end up doing on the day-to-day basis when I'm using Houdini for an environment team. Every day I walk around and I ask my artists, is there something that you're doing that takes, you have to do this boring task 500 times, you don't consider it art, it's really repetitive. Like, can I let you be an artist again? Take away all of the repetition and the boring stuff, still give you all of full artistic control, but you don't have to hand place bricks anymore. Please stop wasting your time doing that. Be an artist. Don't be a robot. And so most of the time, the answer that I get to this is, I don't know. I have been doing this. This is the way I've been making assets for 10 years. And a lot of times I'll stalk an artist and just follow them around and look over their shoulder and figure out like, okay, I've watched you do this 6 times. Here, I can automate this. You never have to do this again. And I'll make a tool so that they do that. And then after I get them roped in on one tool, then they're like, come to me with every single thing. They're like, oh, I may have to do this twice. Could you make me not have to do it the second time? I'm like, I don't know if it's quite worth it. Let me see. But usually you could get them one time and then they're kind of sold on the process. So if you're in a bigger studio, a small, doesn't really matter. A lot of times, especially when you're outsourcing, you kit bash assets. Basically, this just means take a whole bunch of assets that have been pre-textured and isolated and shove them all together to make unique assets at the end. This usually is used to speed up workflow and it ensures consistency. So like if you're making like a stone column, all of the bricks that made up that column look like they were mined from the same quarry. And if you have a whole bunch of different columns, they all look like they were mined and blocked out from the same quarry. And this lowers production costs and a whole bunch of other stuff. The problem with this is you kit bash this thing. We have all of this internal geometry and an artist has to go in and clean all of that stuff up. So if the video will play. Play. Okay. So here's an example of a type of HDA. I kind of just threw in a whole bunch of settings in here as a one-size-fits-all solution for an artist. So they can just bring in their mesh that they want to clean up. I don't know if you could read that number. It's just displaying the poly count on screen. We can see it took out all this nasty geo. And I've just got a setting on here on the HDA just to remove interior geometry. And basically this just checks for occluded geometry, occluded points, and then calls them. So there's no more cleanup and the artist doesn't have to do anything. It's just a one-click button fix. And then using the poly reduce, we can just poly reduce this down and you basically end up with what was a 10K pillar and we brought it down to about 2K and looks basically the same. So that's a really powerful workflow that saves a whole bunch of artist time. And give tools like this to your artists and they're like, oh my gosh, thank you. I never want to mess up with cleaning kit bash assets ever again. And then another thing that a lot of my artists complain about is collisions. Like I hate making collisions for geometry. And so here I basically just am, I have a whole bunch of different ways to generate nice, clean, real low poly collisions for geometry. And this is not a one-size-fits-all solution. It just works on a per asset basis. But there we go. We got really nice. I think it ends up being about 150 polys. Nice, clean collision geometry for an asset. And artists didn't have to think about it anymore. So I'm going to do a quick rundown of that collision generation process. And it's really like, that looks really awesome, but it was really simple to set up. Basically, you take in your original geometry and I VDB it, which just gets rid of all of the stuff on the middle, and then I convert it back into a polygon after the VDB. In another node, I generate a bounding box and fill it with a grid full of points. And then the artist can determine the actual grid size that they want. And then I have a quick vex wrangle to snap all of the points to the nearest point on the grid. And then I group all of the hard angle points. I run a dissolve to get rid of all of the interior geometry or all of the bricker geometry. And then you divide it and you're done. And that's really like a 12 node setup just right there. And it really is that simple. It's not much more complicated than that. And obviously, if you get more complex geometry, you have to do more stuff to clean up this and address different solutions. But it works pretty good in that case. Another thing that I see artists doing a lot at a lot of different studios, so I thought this was a good example of a way that you can get rid of artist repetitive tasks is we have this brick wall or brick material, and then you need it to be like a broken wall. We need destruction on this wall. So the artist will then they'll sculpt bricks that match that material. And then the artist will do the damage on the wall and cut it up, and then they'll go hand place all of the bricks to line up with the bricks on the material. So a solution for something like that, so the artist never has to place another brick by hand, is I have this HDA that I've lovingly called the Wall Buster. And basically they can just use this to punch holes in a wall. They can bring in their own geometry as well if they want. And a thing I also noticed with a bunch of artists is some of them really like procedural control. They just want it to be done. And then other artists want everything to be done or they want like, do all the busy work for me, but I still want to be a complete artist and have complete control over how the cut is made. And some of them may want to place their own geometry or a bunch of different ways that they would want to interact with how they want to be an artist, because they're all different. And so I have this, which is just a blob noise cutting a hole into the geometry. And then go over to just, they can define some custom input geometry and then go inset that and punch the hole out. And this will, you can preview the collision geometry there, and it punches the hole out and then generates all of the blocks that go into the right locations. And then something I added here is, depending on the style of your game, you may want bricks just along the edges, or you may want them to fan farther out. And so I just have a little detection. I'll go farther into like exactly how this HDA would work. Another thing I noticed is a lot of artists are like, well, I just want to I don't want to model the geometry that I used to cut it out. I just want to draw it. And so here is really just the poly draw, and it just takes that poly draw path and then extrudes it and cuts up the geometry. So the artist really can just sketch where they want the destruction to be, and they don't have to worry about anything else. And I kind of hid the polydraw functionality in a bunch of buttons on the HDA that are basically just callback scripts to set different node handles. And if anybody has any particular questions about that, I can talk about that later, or just contact me and I'll walk you through that kind of stuff. And then let that finish up. So yeah, so how are we getting the bricks placed on the geometry in this case? So like I said, art directability, the artist can make any kind of wall pattern they want with stuff like this and control the damage. One of the techniques for creating brick patterns that I have seen a lot is a lot of artists want to make high-res sculpts to get all of the nice detail and everything. Like they'll go into ZBrush and sculpt up a bunch of bricks and then place them and literally like build a wall by hand. They especially want to do this if they want the wall pattern to look really hand-built naturally, because it's hard to get that natural artistic look in Substance Designer for a lot of cases. And so basically I just process that sculpt that they already made, down-res that into game-res bricks, and then get a material put on all of the bricks. And then I have the bricks that match the material that was used to make the brick wall material. And then we start out with our brick wall geometry, and we have our cutter that cuts away the geometry where we want it to be. In this case, I'm just keeping whatever the largest piece is of the geometry. There's probably way more intelligent solutions to this. And then once we cut it up, I isolate all of the seam points where the cut was actually made. And then I basically have all of the bricks lined up to match the UVs on the geometry where it was cut. And then it just puts all of the bricks in place that have been duplicated across the mesh. And then you end up with the artist never having to place bricks again.
Quick question. How do you, I mean, you've got different types of bricks here, and your system seems to know exactly which brick it's supposed to be in what location.
Yes.
How are you somehow, you're querying the UV, and then it's like, oh, this is brick 24? Like, how do you
so
that?
Basically, I'm taking the exact brick pattern. Like, this is a tileable brick sculpt.
Brick pattern.
Yeah, so if I get the brick pattern, or I make it for them to match it, and then that brick pattern I just copy across in the same location as where the UVs are laid out in the 0 to 1 space. And then because I have the brick pattern and the bricks are already in place, it's a no-brainer. It's a really simple solution, and it just looks a lot more challenging than it actually is.
Yeah, that makes a lot of sense. Good. That's clever. Nice.
Okay. One of the kind of powers of Houdini is the Houdini engine and making all of these tools way more accessible to your artists. One of the struggles that I ran into is none of my artists want to use the Houdini engine in Maya. They don't like the attribute editor interface. One of the problems that they ran into this was there's no tooltips, and the layout that you've made doesn't line up with what you have actually created in the type properties for your HDA. It's just in this big vertical layout, and hidden parameters don't work, and yeah. So what I ended up doing was creating a wrapper for the Houdini engine plugin. Basically, I just have this HDA export script that you attach to any HDA that I would make, and it just exports out all of the parm data on the HDA. And every time you update or change new parameters or update the type properties for your HDA, it just exports out a JSON file with the layout and everything for that HDA. And then I can just bring this into Maya. So I've got the same pillar that I had over here, just showing it's got all of the kit bashed bricks set together. And I'm just gonna import this script. And I didn't want to speed up this video at all, just to show that I'm not cheating or doing anything crafty under the hood. This is just how it runs. And yeah, so I import a separate function that I created to just call in the HDA path, and then it calls in the associated JSON file, and it generates a interface in Houdini using PyQt that looks exactly like the interface that you created in Houdini. And I found that once I got this working, my artists were like way more inclined to use it, because I was able to offer them all of the tooltips with the help stuff that I've put in, and the hidden parameters work, and I could create big high-level tools like this that allow the artist to swap around all of the different HDA functionality without having to dig through a vertical list of parameters, half of which didn't work because they were hidden or unloaded. So yeah, here's just an example of the same HDA that I was demoing before. So the artist can bring in their pillar, they can clean up the interior geometry. In this case, I'm just using a quick voxelization. And so that was just the full res voxelization, and then I'll just poly reduce it. And this wrapper is actually very modular, so it just kind of goes into any other Qt layout that you would have. So this is actually built into a separate interface that I have. So the artist can just save out the geometry at one point and then continue working in the same HDA to process it in a different way. So in this case, they're just cleaning up the HDA with the VDBs and then swapping over to the bounding box method of processing the HDA to generate the collisions. So they just, yeah. So in really like 2 minutes, they've cleaned up a mesh, generated collisions for it, and they're done. So big time saver, lets the artist be an artist. So anybody have any questions? Thanks for coming to the talk. Yeah. Sorry.
So how many Houdini artists do you have
At Bluepoint, so we have our effects team, and all of those guys use Houdini, and that's about 5-6 guys right now. And then we have 4 actual like environment artists or / technical artists that use Houdini on a daily basis. And then a lot of our environment artists kind of pop into Houdini to do some simple processes, usually in a really cleaned up interface where we hide a lot of the nodes and stuff so we don't scare them. Environment artists get startled very easily. And so there's some HDA processes don't really work in Houdini Engine maybe, or they're like, maybe they take a lot longer to process in Houdini Engine where they just work more fluidly in Houdini. So.
Do you have people dedicated to helping create tools for like the environment artists?
Yeah, that's basically one of my main jobs. Yes.
I have a quick question about the flag, the fabric waving.
Uh-huh.
So is that animation then, is it kind of like a canned animation in that it's just valid for that single wind field that you baked out?
Yes.
Okay. Is there any way to like blend in like more like real-time like additive noise as well? Or
yeah, you could if you wanted to have like an extra field that you generate or extra vertex animation that goes on top of that. You can totally bake that in and do that as well if you wanted.
Okay.
I don't see a reason as to why you couldn't do that.
Okay, well, thanks.
Cool. Well, thanks you for coming, everybody.